This tutorial will cover optimizing FL Studio's usage of your computer's processor, which is especially useful if you don't have one that's top of the line. I'll start in audio settings, which I touched on earlier. You'll notice here a display for buffer size or buffer length, and depending on your interface and drivers, you may be able to change this setting here, or you may have to hit a button like Show ASIO Panel. The rule of thumb with buffer length is the shorter the buffer, the more strain on your computer's processor, but the shorter the latency. When FL is being overloaded and your processor can't handle it, you'll hear pops and clicks when you try to play back your project. So if you're recording MIDI or audio, you'll want to find the right balance between low latency to reduce the delay during recording and a buffer size that won't overload your computer. Personally, I work at about 512 samples or 12 milliseconds of latency, but this is up to you and what your computer can handle. Your audio interface or sound card can make a big difference as well. A high-quality audio interface can cost anywhere from $100 to over $1,000, but it will have a big impact on how efficiently your DAW operates. A crummy built-in sound card, for example, may get pops and clicks at 512 samples of buffer length, whereas a fancy interface playing the same song might have no problems at all. You should also try switching to different drivers to see which is more efficient. On most PCs, ASIO drivers are best. Under the CPU header, multi-threaded processing options will help FL make better use of multi-core processors. Not all plugins behave properly with this on, so if you have stability problems, try turning it off. You can leave Smart Disable on, and I'll get to it a little bit later. Align tick lengths can sometimes reduce CPU usage of some plugins, and it can't hurt to leave on. Under the mixer header, the key option here is resampling. This applies only if you're transposing audio, for example, if you're playing a kick or a snare drum and pitching it up or down. The lower down on this menu you go, the more usage of your processor, in exchange for better sounding transposition. You can generally leave this at 6-point Hermite unless you have a lot of artifacts when playing back in real time. One simple way to reduce processor usage and improve performance is to go to Tools, Macros, Switch Smart Disable for all plugins. If you look at any given plugin in the upper left, you'll see Smart Disable as something you can check or uncheck. Smart Disable will stop processing a plugin if it hasn't been active for more than a few seconds. However, it won't be effective at all if all of your plugins are active all the time. It works best if you're using some plugins in part of the song and some plugins in another part. Depending on your type of driver, you might see these options. You can try Use Polling or Use Hardware Buffer to improve performance. 32-bit buffer allows for more mixing headroom, but does not impact performance. If you're using ASIO, you can try Mix in Buffer Switch to improve performance. Triple Buffer is a last resort tool that significantly increases latency but may help reduce pops and clicks. There's one more technique. If you're absolutely maxed out, you might consider taking an intensive plugin, soloing it, turning off the master effects, and then rendering that plugin for the whole song. This is what's known as bouncing down a plugin. You can then save a new version of your project and delete the plugin along with any effects, using the audio render instead. This saves CPU, but of course you can't change the plugin or its notes without going to the old project.